Ladies and gentlemen, moving on to our sixth keynote speaker for today, Associate Professor TS ChM Dr. Nik Ahmad Nizam Nik Malek is a Director of Center of Sustainable Nanomaterials CS Nano, University Technology Malaysia. Lecturer at Department of Biosciences, Faculty of Science, UTM. As a professional chemist and technologist and chartered chemist, his expertise is applied material science, where his research area involves using materials in biological and medical applications. He is a program leader for UTM Transdisciplinary Research Grant UTM DR17, which is antibacterial wound healing application of bio-inspired green silver nanoparticles. His current major research is the development of inorganic antibacterial agents, especially green silver nanoparticles. So his title for today is Sustainable Nanomaterial, Biosynthesis of Silver Nanoparticles. Please welcome, Doctor.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, Doctor.
Okay, thank you very much, Ms. Aisyah, for the chairperson, as a chairperson for today's event. Okay, so welcome everyone to BioNanoSem or Bionanotechnology Research Seminar. So this is my part here where I will give you the information, some information. Hopefully for my part today, I will give light information about the research that we have done, okay, but not too technical. So maybe you can grab this information, okay, from my talk today, and then this is actually good for your future research, okay. So the title for my talk today is Sustainable Nanomaterials, which is the biosynthesis of silver nanoparticles. So today we have heard about the biosynthesis, okay, biosynthesis of the metal nanoparticles from the plant extract, from the, what they call this, microalgae, right, from other resources, and also different metal, and not only just silver, there is also metals, okay, other metals like zinc oxide and so on. Okay, so today's talk, I go to the next slide. So this is my research project that I obtained, okay, for the last few years. This one is very big, UTM Transdisciplinary Research Grant, and with the title of Antibacterial Wound Healing Application of Bio-Inspired Green Silver Nanoparticles. So there are actually 5 projects under this program, so which is a very big program lah. Okay, so it's involved biosciences and also chemistry. It started 2 years ago, and there are actually many things that we obtained from this project. Okay, because it's a research. Research is something like we have the what they call this trial and error, and then after that we find a new thing, we explore new things on that research. Sometimes it might be deviate from the proposal that we get that we prepared at the early stage, and then after that we try to modify it. So that is actually research. So we are not stick to the proposal, but we try to expand it. We try to look at the different angles. Okay, and then another one. So Alhamdulillah, I got this FRGS grant, Green Biosynthesis, Characterization, and antimicrobial mechanism of silver nanoparticle using Ficus lectoria. So Mas Cotek lah. Okay, Alhamdulillah, we got that. Okay. Okay, we move on to the next slides. So, so I'm from Sustainable Nanomaterials. So this is actually the combination of the word sustainable and also nanomaterials. So sustainable, if you want to go, if you want to understand the definition of sustainable, actually I like to look at the what they call this, the define definition of the sustainable, the word sustainable itself. Okay, so the word sustainable itself is adjective. number one here is able to be maintained at a certain level or level. Okay, number two, able to be upheld or defended. Okay, and then there is also I put it here, adopting sustainable practice, whether large or small, can have significant impacts in the long run. Okay, so sustainable here is something that we want to maintain it in the future. So that is sustainable. Sustainable meaning that is something related to a good future, related to a good environment, okay, related to something that will not harm to us. So that is a sustainable. Nanomaterials is a combination of the word nano and also materials. So if you can see here, okay, in the slide here, there are several types of nanomaterial. First, it can be divided into inorganic nanomaterials, organic nanomaterials, and so carbon nanomaterials. So for the inorganic nanomaterials, like for example, silver, aurum, palladium, copper, okay, and then organic nanomaterials, for example, like micelle, liposome, hybrid, and so on. Carbon nanomaterials, for example, like graphene, fullerene. So when you talk about sustainable nanomaterials, is something like whether the source of the synthesis of these nanomaterials is come from the sustainable resources, okay, or the application of these inorganic materials for our sustainable future. So that is what I can say about the sustainable nanomaterials. So in this talk, I will talking about the biosynthesis, which is one of the biosynthesis is one of the main aim in the sustainable nanomaterials. First, we'll look at this issue in the synthesis of nanomaterials. So as you know that, okay, if we want to synthesize silver nanoparticle, okay, or silver particle, or silver oxide, or metal oxide, there are actually many techniques that we can do. Okay, if you can see here, there are top to bottom. Top to bottom meaning that the it's come from the very big particles, and then we are using like ball milling, laser ablation to make it smaller, to come up with a particle which is smaller. Okay, so that's top to bottom. For bottom to up is that we have the ion, okay, for example like silver ion from silver nitrate, and then we are using all of these techniques, okay, either chemicals or using green synthesis technique to come up with the particles, okay, to produce particles, which is in this case we're using Ag plus, okay, not using, actually the process is that we have a silver plus, and then we are using reducing agent to come up with a silver nanoparticle, okay, Ag plus, and then Ag0 here, okay, Ag0 here, okay. Talking about the nanomaterials, okay, is Ag plus to Ag0, okay. So we have the reducing agent here, okay, we have the reducing agent here. So this in a typical situation, okay, in typical chemical synthesis, we are using chemical reducing agent, okay, for example like sodium citrate and also sodium borohydride. But there are actually problem with these materials where it is dangerous and also expensive, okay. And at this stage, okay, if we are using this chemical reducing agent at this stage where we want to discard the supernatant, or we want to collect the silver nanoparticle, there are actually additional steps, which is to treat this waste treatment, okay, to treat this waste treatment. So it's actually add to the additional problem, okay, because we want to treat the toxic materials, toxic chemicals from this process. Okay, right. So if you see actually in the bottle of the sodium borohydride, you can see there are 4 labels of safety. So you can see You see here there is a flammable, okay, and there is also a picture of the tengkorak here, okay, showing that it is really toxic, it is harmful, and also it's corrosive. So if you use sodium borohydrate as a chemical reducing agent, we can ask the question whether the synthesis process considered as sustainable or green approach. I think it's not. And how we can handle this toxic waste. What is the production cost of silver nanoparticle and how its toxicity effect to human, flora, and fauna. Okay. So I think I need to go faster. Okay. So these are the biosynthesis of the silver nanoparticle. Okay. The idea, okay, is to replace the sodium borohydrate, okay, using biological resources. So the plant extract is our selection, okay. But actually there are other biological source that we need to consider, okay, that we can consider. So the selection is actually what is from our research, is that from our project. There are a few things that we need to consider before we can select this sustainable reducing agent. First is high reducing ability. Second, high antioxidant activity. Third, high flavonoid and phenolic compounds, and also it's abundant. So these are the analysis that you can do. Okay, if you want to use this biological resource as reducing agent, okay, there is a combination of organic and also analytical chemistry. So where you can use chromatography or spectroscopy technique, you can determine the TPC, TFC, DVPH, FREP, and also using FTIR to know the functional group, and also use other suitable techniques. Okay. So thanks to Atia, one of my student. Okay, she's working on this biosynthesis of silver nanoparticle, and she has determined the antioxidant activity of some of the important plant, Malaysian herbal or ulaman. Okay, and then what's important here from this data is that there are actually a good correlation between this antioxidant activity and also formation of silver nanoparticle, where the higher the antioxidant activity will result on the higher formation of silver nanoparticle. So in this case, Justicia gindarusa has a very low antioxidant activity, very low FREP, okay, and also very low strength of ferric reducing capacity, and also very low DPPH percent. And then it gives higher, lower formation of silver nanoparticle as compared to Persicaria odorata. So Persicaria odorata is the kesom, okay, kesom. It has a high antioxidant activity and also high reducing capacity. So there is actually correlation between this antioxidant activity and also the formation of silver nanoparticle. Okay, and we have done this, okay, synthesis of silver nanoparticle from the kesom, and then from this optimization, from the experiment that we have done in the lab, so we optimize the synthesis parameter, and then we copyright the synthesis itself, the process of manufacturing this silver nanoparticle itself. Okay, but then there is there's a disadvantage of biosynthesis silver nanoparticle is that the particle size or particle shape is not homogeneous, it is heterogeneous. Okay, so actually there is also this advantage of biosynthesis. Okay, but it depends on the application. Okay, I think I need to go a little bit faster, okay, because the time is not it's not too much on this. Okay. Okay, I want to share with you a little bit information about how we can design sustainable project for developing biosynthesized nanomaterials. So this is actually very good if you want to go into commercialization of your research product. So what we can do is that we can use this TRL or technology readiness level strategy, okay, which is actually have been done introduced by NASA, okay, and then MOSTI, Malaysian Ministry of Science, Technology and Innovation use this for the identifying the research level, okay. So there are actually 9 level, TRL1 up to TRL9, and then it start from the basic principle or research hypothesis up to the come up with the prototype and so on. So actually for us, sometimes we just involve on the TRL1 to TRL3 only. Up to the papers is on the up to the proof of concept. But when it comes to the TRL4 to the TRL9, we need to have more funding on this. So maybe in the future, what you can do is that, okay, for the all of the researcher here, okay, what you can do is that you can actually plan ahead your research, not just only up to the proof of concept, but you can go up to the RL4 and so on, okay, up to the technology development and also business development. Okay, as a summary for my talk today, okay, so actually my talk today is not much on the technical issues, okay, and if you want to ask related to the project that we have done, so please let me know, okay. So what I can summarize from this talk and also from the experience in doing this research related to the sustainable nanomaterials is that, okay, synthesis or preparation of materials using green or sustainable approach is considered as one of the area in the sustainable nanomaterials. Okay, and then for the biosynthesis of silver nanoparticles, actually we solve the issue of toxic and also hazardous substance, especially when we use chemical reducing agent. Okay, and then if you want to use plant materials, if you find out that there are possible plant materials, you need to do plant analysis, okay? And then you need to understand a little bit about the organic chemistry and also analytical chemistry. Because if you can understand the phytochemical compounds in the plant, you might be able to reduce some steps in the research, okay? Maybe if the antioxidant activity of the plant is really low, okay, so might be it does not contribute to the formation of the silver nanoparticle. So it's not just only for plant materials. Maybe there are actually biological resources that we need to we can consider. For example, like honey, okay, madu, and then maybe the bacteria, the isolated bacteria. And then there is actually, if you use this sustainable nanomaterials, it actually will give an advantage for future commercialization, where it can reduce the production cost and also we can reduce the what they call this impact, negative impact to the environment. So these are the ongoing and future projects of me lah actually. Okay, first is fabrication and characterization of biosynthesized green silver nanoparticles immobilized on synthesized zeolite. So we are trying to immobilize this green silver nanoparticle onto the other carrier system. Okay, and then we want to apply this green silver nanoparticle as antibacterial wound healing agent, and then we want to and also we want to try to synthesis this silver nanoparticle using various source, algae, honey, marine bacteria, isolated bacteria, enzyme, and so on, for various application as antimicrobial agent, antibiofouling agent, and so on. and various angle of study. We also what do you call this, involve computer simulation. We are trying to commercialize some of the product. We study the physical chemical properties, want to apply it in biomedical application, and so on, so on. Okay, so there are actually many room of improvement for the biosynthesis of silver nanoparticle. So I would like to acknowledge all of my postgrad students, okay, my collaborator, and also the research projects, the funder of this project. Okay, so I think with that, thank you very much. You can scan this QR code, okay, using your QR code, not using my Sejahtera, using your QR code, okay, to see my, it will go to my website, okay. So with that, Aisyah, I will get back to you.
Okay, thank you, Doctor, for the wonderful sharing. Okay, let's move on to the Q&A session. Okay, Doctor, we have one question in Facebook.
Okay, do you want me to read this?
I can also read to you.
Okay, go
Okay,
on.
Doctor, in your previous research, what is the ratio between plant extract that be needed to reduce silver ions?
Okay, for the ratio, there is no specific ratio that student did so far actually, because when we want to synthesis silver nanoparticle, okay, we come up with try and error. We try to come up with 1 millimolar of what do you call this, 1 millimolar of silver nitrate, okay, silver nitrate, and we try to come up with a different what do you call this concentration of the plant extract. Okay, so the ratio actually is different, depend on the plant extract that we use. Like I said in my presentation, okay, each of the plant they have a different antioxidant activity or different fat value or DPPH value. So different value will give a different what they call this formation of silver nanoparticle. That's why actually one of the techniques that we use before we go further is to optimize the synthesis parameter of the silver nanoparticle, the synthesis of the silver nanoparticle using this plant extract. Okay, so there is no specific ratio on this. Okay, it depends on the plant itself. Okay.
Okay, Doctor, we have another question. Okay, Doctor, what is your comment or prediction on the continuous use of plants for silver nanoparticle synthesis? This is pandemic time. It is expected that the use of sanitizers with AGNP will be booming over the years.
Yeah, actually, based on my prediction, yes, based on my prediction, we will use this silver nanoparticle, especially not just from plant actually. There are actually commercialized silver nanoparticle, especially from China lah. Okay, especially from China. So they produce silver nanoparticle from various techniques. Sometimes they make it what they call it, they did not show the method that they use. They just prepare in the lab and then sell it in the form of colloidal, colloidal silver. Sometimes very high concentration of colloidal silver, and then the manufacturer bought this here and then put it as one of the active ingredient in the hand sanitizer. Okay, hand sanitizer. So actually silver nanoparticle ni it can be used for hand sanitizer, but I do not want to claim that it can kill what they call the virus. So it's actually it's dangerous to say that. Okay, however, this silver nanoparticle, if we can use it properly, it can be used to kill most of the microorganism, which is not just only bacteria but also some of the virus and also fungus. So that's actually what I want to say lah. But based on the my prediction, the silver nanoparticle will be used in many application, not just in the hand sanitizer. However, it's based on our competitor lah. Okay, so that's my answer.
Okay. Thank you, Doctor, for the answers and the wonderful sharing.